What's going on, everybody? This is Mr. Diamond, and I'm going to work out two basic-ish. They're not super easy, but they're some pretty basic forms of easy / cis-trans isomerism naming problems. Let's scooch this out of the way so it's a little more light coming to this. I'm going to scooch this, and we're going to scooch this. There. I think that looks a little better. Now, remember that this chapter also is bringing in amines and also these guys right here, which hopefully you recognize as amides. So make sure that you are up on those namings. Now, I obviously have named at least one of them, but we'll make sure that we're able to do that kind of comfortably. Okay, first example is going to be name to structure. So we're going to write this down here a second time just so it's a little more clear. So I'm going to do, it is cis, trans, parentheses, hex, 1, 4, dienamine. I forgot the di up here. This should be di. So cis-trans, hex, 1, 4, dienamine, which is pretty fun to say, dienamine. Now, when you're drawing your structures for this, up until this point, you were able to kind of draw your structures and just kind of go. Highly, highly, highly recommend use a pencil. If you want to go back over it with a pen afterwards, that is fine, but like you should probably be using a pencil for these because the cis-trans and the easy stuff may mean you have to flip around what direction your structure is going. Okay, so first thing I'm going to do is I'm going to see this hex, and that hex tells me that there are 1, 2, 3, 4, 5, 6 carbons as my parent chain. There is a double bond on position 1. I believe that should actually be position 2. Man, I just copied down my example completely incorrectly. So we're going to fix that, and we're going to fix that. Okay, much better. So on position 2, we need to put a double bond. So our double bond goes here. So that's between carbons number 2 and 3, and then this would be between carbons number 4 and 5. Now we also, though, need to make sure that this first double bond is cis, and then this second double bond is trans. Notice there's not numbers going with it on here. It's just listing them in the order that they show up. Now, to fix this, you could go, oh man, I'm going to have to like erase this whole second half and make it go down. But remember, you get to choose how your molecule is represented. So I actually am going to erase this right here, and I'm going to put it right there. And now this first one is cis. It's entering and it's exiting the same side. If I tilt it vertically, they're coming in and out the right side. And then this other one on position 4 and to carbon number 5 is entering one side and it's exiting the other. Then I've got 2, 4. That's where the 2 and the 4 are. Di is 2, and that's ene. But then it also says amine, which amine is going to be a nitrogen with some amount of hydrogens attached to it. So normally nitrogen would be NH3, but if I'm going to have it single bonded to something, so I'm going to do it like this. I'm going to do NH. It would have been 3, but because it's single bonded to something, that cuts out the need for one hydrogen, and it'll actually be NH2. Now, you then may want to, if you're someone like me and you have really preferred having all of these things be in pen, so they're kind of very easy to tell what is what. I'm going to go ahead and re-go over this in pen. And there we have it. It is a 1, 2, 3, 4, 5, 6 carbon chain. On carbon number 1, 2, there's a double bond that enters and exits on the same side. On position number so this is 1, 2, 3, 4. Position number 4, it enters into a double bond and it exits an opposite side, so that would be a trans. And then this is amine on carbon 1 because there was no number associated with the amine right here. So that is my first example problem. And don't worry, I'll have a bunch of other ones for next week whenever we actually start practicing it. Now, going to our next set, our next example problem, we've got this bad boy right here. And I'm going to do it over here because I don't want to redraw it, since apparently I'm bad enough that every time I redraw it, I've been screwing it up. Let's first get our parent chain. I'm going to not use blue because that would be very confusing. So our parent chain, 1, 2, 3, 4, 5, 6, 7, 8. It looks like 1, 2, 3, 4, 5, 6, 7, or 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So yeah, 8 looks like, so it's 8 carbons with a double bond. So that would be octene. And the double bonds are located on position number. Now, we need to figure out what direction we're going to number this from. If this was 1, there'd be something on it. If this was 1, there would be something on it. So that's not good enough. This is position 2. This is position 2. There would be nothing on it. Position 3, there is a methyl and a double bond. Position 3, there is a methyl and a double bond. So we're still completely identical, but position 4 here and position 1, 2, 3, 4 here, this one does not have anything. This one has 2 carbons coming off of it. So we're going to actually number from this top direction. So that's 1, 2, 3, 4, 5, 6, 7, 8. So our 2 double bonds are starting at position 3 and 5. So it's going to be diene, actually, is our ending. Okay, now we need to identify our other pieces of it. I've got a methyl and I've got a methyl. So these are on position 3 and 6. We've got dimethyl. And then what other colors do I got? We'll use this one. We've got this bad boy right here. So that would be a ethyl on 4. And then we've got our end pieces, or our edge pieces right here. So this is an amine, but it is actually, that should be NH2. Man, look at me trying to go too quickly. So it should be NH2. That's what I get for going too fast. I'm trying to get this because I didn't get it done on time, so that's what I get. Anyway, these guys right here are amines, but they're attached to a carbonyl carbon. They're attached to double bonded oxygens. So that means that on position 1 and 8, those are not actually amines. That would be diamides. You change it to IDE instead of INE if it is attached to a carbonyl carbon. Now, the last thing we need is we have enes. We have to identify what type of double bond they are. Can we do cis-trans naming here? Well, no, we cannot, because these bonds are, both of them have extra pieces attached to them. So it wouldn't be clear enough to identify them as either cis or trans. So I'm going to switch to an even more color, or another whole color. And we're going to look at each side. So starting here on this side of this bond, we've got carbon and carbon, so that those are tied. They're attached to 2 carbons. This carbon is attached to a hydrogen and then has 2 carbon bonds. This one has 1 carbon and 2 hydrogen bonds. So this here would be CHH. This one would be, it counts as actually 2, so it'd be CCH. The first carbon is a tie, so that doesn't affect anything. But the second thing it's attached to, the second highest priority, this side is a carbon, this side is a hydrogen. So this is our priority point for this side of it. And then up here we've got carbon, 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 and this is all hydrogen, so this will be our priority point. So these are on the same side. So this would be 3Z. And then on 5, we've only got one thing over here, so this side has to be the priority. I'm going to use one more color. This one has to be the priority. This is a carbon, this is a carbon, this is all hydrogens, this has a carbon. So this one looks like it's going to be Z yet again. And then, boys and girls, and those gender nonconforming, we finally have to bring it all together. So we're going to have to list these in alphabetical order. This is going to go at the very ending because it's going to be, the amide is modifying this E. So this is going to go back here. We worked too long, the lights went out. Ethyl comes before methyl because we ignore the suffixes. So our actual final name, if I scooch this up a little so we can write it all out here. I apologize that when it's dark, it's making it a little bit blurry. So we're going to go we start with our E and Z configurations. Those go out front. So we're going to do parentheses, 3Z, 5Z. Notice on that one, we don't just list them in order. We actually associate a number with them. Then we can begin 4-ethyl 3, 6-dimethyl oct 3, 5-di-N 1, 8 diamide, which is a pretty absurdly long name. I said I was going to do an easy one, but I guess I tried to cram too much fun stuff for us to include on there. So this is 3Z, 5Z, 4-ethyl 3,6-dimethyl oct 3,5-di-N 1,8-diamide. Very lengthy, not nearly as fun to say as some of the earlier ones, but it is at least very, very clear of exactly what you're talking about. You've identified that there are double bonds on 3 and 5. At the ends on 1 and 8, there are amides because there's 8 total carbons. The double bond on 3 is a Z configuration. The double bond on 5 is a Z configuration. On position 4, there's an ethyl, and on 3 and 6, there are methyl groups. So that's a lot of information that we had to come across. This molecule looked kind of simple, but was actually kind of complex. But here would be our name. I hope that makes sense to you guys. If you have any questions, please send me an email. Otherwise, we're going to cut this video off. This is Mr. Diamond signing off. Have a great rest of your day, everybody.